we're going to have a look at the product rule. Before we have a look at the product rule, you need to understand what all this means. Okay, so I'm just going to try and explain what's dy dx, what does dv dx mean, because it's very important when you get onto more difficult questions that you actually understand, you know, what's dr dt, what's dv dt, what the hell does that even mean? So I'm going to start off here, and the way I have been writing a function so far is, let's say f of x equals an x squared. Well, if you want to differentiate that, you can look at your log tables. Yes, we have an x to a number, so we have an x squared. You bring the power in front, you subtract 1 from the original power, and you end up with 2x. That's my function. We know what it looks like. It's a U shape, etc. And then that's the formula for the slope, depending on what part of the function you're looking at. So I wrote it as f of x equals x squared. I could have written it as y equals x squared. We know that they're the same thing. And if you write it as f of x, then f dash of x says, oh, this is the differentiation of it. Or this is the formula for the slope or the rate of change. It's just indicating what it is. Oh, here it's the little dash. But if I write it like this, you know, I don't put like, well, y dash or anything like that. What I'm trying to say is, if I want you to differentiate this, well, I want you to differentiate the function that I have called y and the variable that this function is written in is x. So if you ever see dy dx, it means they want you to differentiate the function called y that is written in terms of x, or in other words, the variable that's here is x. I could have written this as f of a equals a squared. Oh, well, the differentiation of that is, again, I have a variable a in this situation to the power of 2. Yeah, that's fine. That's exactly what's in the log tables. It says bring the power down in front and subtract 1 from the original power. So, you know, it doesn't matter what the variable is. Here it was x. Here it was a. So let's have a look at this. You know, if I said, okay, instead of f of a, I'm going to call it y equals a squared. Now, if I ask you to differentiate that, I'm asking you to differentiate the function called y that's written in terms of a. The variable is a, which means the short way for me to say that, because again, we're lazy, is dy. So differentiate the function you called y that's written in terms of the variable a. So in this situation, it was y in terms of x. So you'd ask them to differentiate the y function that's written in terms of x. Or over here, it's written in a different variable. So it's the y function, but the variable is a. So they want you to differentiate the y function that's written in terms of a. It's still 2a, it's still the same thing. You know, you bring the power down in front, you subtract 1 from the original power. So what does all of this mean then? This is the product rule. I want to be able to understand what it's actually saying. So let's just have a look at a function. Let's say, let's have a look at a basic one. Okay. So if your function was written like this, well, you actually have two options here. You could, one, maybe rewrite it and then differentiate. See if there's anything here that helps. Or you could too leave it as it is and see if there's anything here that helps. I'm going to do it both ways because I want to show you that we're going to get the exact same answer. So, you know, you always persevere and clean up something so it gets to its simplest form. So 1, I'm just going to rewrite and then differentiate. Okay. So I'm going to just say, right, I'm going to call it, instead of f of x, I'm going to say y equals, I'm going to multiply this out. When you multiply that out, you end up with x squared plus 4x plus 3. And now I go to my log tables. I'm hoping that something here is going to look like that. So x squared, yeah, an x or a variable to be squared. I can bring the power down in front and subtract 1 from the original power. So if you want me to get the rate at which this function is changing, so, you know, it's a U-shaped graph, etc. If we want the slope of this function, then I want you to differentiate the y function that's written in terms of the variable x in this situation. And this is where, you know, this looks like this. So I'm going to bring the power down in front and subtract 1 from the original power. You bring the power down in front, you subtract 1 from the original power, you get 2x. There's power of 1 here. So you bring the power down in front, you subtract 1 from the original power, you get a plus 4. And, you know, I've looked at when you differentiate a number before. The long way about it is to say, oh, it's 3 times x to the power 0. You bring the 0 down in front and subtract 1 from the original power, which is 0. So any number differentiates to 0. And you can have a look at that in a previous video if you're still not sure why. So there we go. If you gave me that question, one of my options was to rewrite it. I did, I just multiplied it out. And then I differentiated the y function that was written in terms of x using the left-hand side of the page here, which is the easiest thing to do, usually. Now, let's say I didn't even think of rewriting it. Method 2 is, you know, didn't even cross my mind to rewrite it. So I just write it as, leave it as it is. Y equals x plus 1 times x plus 3. And I'll go to the log tables. I want to differentiate that. Is there anything here that even has brackets in it? No. Okay, so now I'm on to the next part of the page, the product rule. Product means multiply. So if you look here, if your function is written as y equals something times something. All right, well, I see that. I have a something. And then so u is the x plus 1 and v seems to be x plus 3. You know, put in brackets, but it doesn't matter, you know. I'm only just in that side. Have it. Yeah, you can actually just, we don't need the brackets. I just kind of looked at that and wrote it down. Okay, so now what does this say to do? We're following the product rule because we have 2 things multiplied. So do I want to differentiate the y function written in terms of x? Yeah, I want to differentiate this. They're going to ask me at some point to find the slope or, you know, find the differentiation of that. So yeah, my end goal is to differentiate the y function that's written in terms of x. And it tells me that if you want to do that, if you want to differentiate your function, then you need to get u, have it, times dv dx. Well, what does that mean? They want me to differentiate the v function that has the variable x in it. Well, there's the v function that has the variable x in it. So they want me to differentiate this. How do I differentiate it? You know, pretend it's just a question on itself. If you had x plus 3 and you just want to differentiate it, look, x to the power of 1 plus a 3. So you can use this one again. This is the most common one to use. So x to the power of 1, you bring the power down in front and you subtract 1 from the original formula. What else do I need? Plus v, have it, there's v, times du dx. What the hell is du dx? Well, they want me to differentiate the function that I have in front of me that has u, called u, and it's written in terms of x. So there it is. They want me to differentiate this. So du dx, again, most common one, bring the power in front, subtract 1 from the original power, just happens to be a 1 again. I've picked a very easy question here. So I have everything I need for my formula. I just need to fill it in now. So if I want dy dx, yes I do, I need to get u times dv dx plus v times du dx, and then I need to clean that up to make it as simple as possible, which means dy dx is equal to x plus 1 plus x plus 3, which is 2x plus 4. That's what I got a minute ago. It doesn't matter which way you do it. Often there's a few ways to differentiate something. I will always, if possible, use this part of the page. If I can't, I move on to the product rule. If I can't use the product rule, I move on to the quotient. If I can't use the quotient rule, I'm left with the chain rule. I have to be able to do one of these things here usually. Okay? We'll have a look at the quotient and the chain rule in another video.